vibration and waves, and also the formulas that you need to know. Alright, specifically I'm going to guide you on things that you're supposed to know under vibration and waves and how you should come about them. So the first thing that you need to know under vibration and waves are the formulas. And apart from the formulas, you need to know how to collect data. Okay, very, very important. Then the third thing, you need to know situations in which they ask questions. So with these three things, you can be able to answer different questions. So let's start with formulas. When you talk of vibration and waves, let me just give an example of a spleen. So when a spleen vibrates, what is going to be produced is a wave. That's the reason why we are looking at vibrations and waves. So a wave is going to be produced, which is going to be the longitudinal wave. I think you and I know that. Now, as the spleen is vibrating, it is going to produce a wave, isn't it? Now, there is this important law when it comes to the spleens, which is called Hooke's law. You and I, we know that Hooke's law states that the force which is going to be applied, or the load which is going to be applied on a spleen, it is going to be directly proportional to the extension of a spleen, or is directly proportional to the extension of the spleen. What it means is, let's say we have a spleen here, which is hanged on a fixed position here. Let's say this is the fixed point, and we have a spleen here. So what is going to happen here is that if we put a load here, or the mass M, the spleen is going to extend. Now what is going to happen here is that if this spleen is not going to reach the elastic limit, when you talk of the elastic limit, is the point of limitation of a spleen. So if we say this spleen here is having the elastic limit of 20 centimeters, so meaning to say if we put the mass M here on this spleen here, and this spleen extends up to, let's say, 25 centimeters, meaning this spleen can't go back to its original position because it has exceeded the elastic limit. Alright, so that is very, very important to know. So Hooke's law states that the force or the load which is going to be applied to the spleen is directly proportional to the extension, provided that the elastic limit is not reached. So now, from this alpha, we are going to have two things, which is the equal sign and also the constant K, which is the constant of the spleen. So the constant of the spleen depends on how stiffness the spleen is. Okay, the stiffer the spleen, the higher the constant K. So I'm talking about this one. This one is called the spleen constant. So when it comes to the spleen constant is bigger to the stiffer spleens, or the higher the spleen constant, the stiffer the spleen is, and this is the extension. So usually extension is measured in meters, and here we know to say that this is force, or we can say the load, and this one is going to be measured in newtons. So therefore, for the constant of the spleen, it is going to be measured in newton per meter. Where is this one coming from? Let's say if we make K the subject to the formula, meaning we're going to divide by XE, isn't it? So therefore K is going to be equal to force divided by X, which is the extension. So we know to say that force is measured in newtons and extension is measured in meters, and this division is same as per. That's the reason why the constant of the spleen is measured in newtons per meter. So that one is very, very important to understand. Now let me just do this. We have come up with the first formula, which is the formula for Hooke's law, which is force is equal to the spring constant multiplied by the extension. But you and I, we know when you talk of Newton's second law of motion that force is equal to mass multiplied by acceleration. But let's just imagine that we have a spring here which is fixed to the block. Let's say this one is the block, and we have a spring here like this one. Now let's just imagine that this is the initial position where we are going to say it is x initial, and we try to stretch this spring here. So at least it's going to move a bit, something like this, up to this point here where we're going to say this is the extension, the final extension, meaning to say that extension is equal to change in final minus change in initial. This one is also very, very important to understand. So if they have given you the initial of the spring to be 20 centimeters, and this spring here has extended up to 40 centimeters, so meaning to say for you to find the extension, you need to say 40 centimeters minus 20 centimeters, which is equal to 20 centimeters. But you and I, we know that this is measured in meters, so you divide by 100 centimeters, and it is going to be 0.2 meters. So this is how you're supposed to go about it. But what I'm interested in here is let me just erase this one. I'm interested in you knowing what happens when you stretch a spring. Right? When you stretch a spring. So if we use let me just use this one here. If we use the XY plane, this is X and this is Y. When you're going on this side here, you're going to the positive side of X. When you're going on this side here, you are going on the negative side of X. That is very, very important. So as this spring is stretched, it is going on this side here. As you see, it is going on this side here. So it is going on the positive X axis. That's the reason why most of the times, or why I'm using X here as the extension, because as you are stretching something, you are stretching it horizontally on the X axis. So it is going on this direction. That's the reason why we're having a positive here. So this one is going to be positive, and this one is the force which is applied on the spring. But what about when you let go this spring, meaning the spring is going to go on this direction? So this is what we call the restoring force. The restoring force, let me just write it nicely. The restoring force is the force which brings back the spring to its original position. So we have the restoring force. Now, guess what? What is going to be the symbol for the restoring force, or the sign, I mean, for the restoring force? Since it is going on this direction, it is going to carry a negative. This restoring force is also known as the force done, or the work done, let me say the force of the spring. Okay, so meaning to say extension here is negative, then here extension is positive when you go on this direction. So what is going to be the formula for the restoring force? So therefore restoring force is going to be equal to K then negative X. So when I just do the assumption properly here, we are going to a force which is going to be equal to negative Kx. So that is where this negative is coming from. Now as the spring is stretched and you let go, you're going to find that it is going to accelerate as it is moving on this direction here. It is accelerating. Now as it is accelerating, the only force which is applying on the same spring is the restoring force. So for us to find the maximum acceleration of this spring, we are going to relate it with this one here and use this one here, because this formula here is coming about because the spring is wants to come on the original position, which is x initial. So we notice that this is false and this one is false also. So false is equal to false. So what it means here is that we know that this restoring force is equal to this one, so we can just say negative kx, and we know that this force here is equal to that, so we can just say mx. This is the acceleration in the x-axis. So making ax, which is acceleration, the subject of the formula, I'm going to have this one here, ax, which is going to be equal to negative, then open bracket, k divided by m, then multiplied by x. So you're going to understand why I've separated this one here, and the reason why I'm putting this one inside the brackets, the reason. Otherwise, just the same as you can say kx divided by m, there is no But what is going to be the units for force? You know that force is measured in newtons, isn't it? But what is going to be the unit for acceleration? Acceleration is measured in meters per second squared. So that is very, very important to understand. Now, you are going to find that when you talk of velocity, velocity is highest, or we can say the Vmax is going to be on the point of initial. Alright? That is when you are going to find, or that is when you are going to have the Vmax, which is the maximum velocity. The maximum velocity is going to be at the initial position. So that is very, very important to know. So apart from this one, let's also do this. So far we have those formulas. So I'm going to give you an example so that you see what I'm talking about, and I think that one is going to be very easy for you now. Formulas that we have talked about. So number one, we have talked about the formula for Hooke's law, which is this one. Then number two, we have talked about the restoring force, which is Fs, which is equal to negative kx. The second one is the force when it comes to Newton's second law of motion. Then, after doing the assumption, we have found that the maximum acceleration is equal to negative k divided by m, which is the mass, multiplied by the extension. So this one is very, very important to know. So here you need to get negative acceleration, and the reason why we are getting the negative acceleration, remember there is restoring force, and as the spring was moving, it was pointing on the negative side of x. So that is very, very important to know. So let's talk about other formulas that you need to know. You and I, we know to say that period is equal to time divided by the number of oscillations, isn't it? I think this one is just very simple. Period is equal to time divided by the number of oscillations. This one you learned it at grade 12 when you're looking at interval measurements, simple pendulum, and you know to say that this period is measured in seconds. Then apart from that one, frequency is equal to the number of oscillation divided by the time, which is same as 1 divided by t. This one is very, very important. So we are saying frequency is equal to 1 divided by the time taken, or the period, which is the time. Now what is going to be the SI units for frequency? Hertz. But sometimes you can also have s to the power negative 1. So this one is 1 and this one is division, and we know to say that the units for time are the seconds. So expressing this one here into negative index, we are going to have s to the power negative 1. So hertz is equal to s to the power negative 1. So that is one thing that you need to know. So this one is D, then E. We have talked about this one here, time taken divided by the number of oscillation. Then F, we have talked about frequency, which is equal to 1 divided by 10. Now let me talk about this one here. You have learned about how to find the angular velocity. So you and I will know to say that angular velocity is equal to theta divided by time. This is angular velocity, isn't it? Now this theta is the distance, and where are we going to get this distance? Let's do this. If we talk of a circle, a circle adds up to what? 360, isn't it? This 360, when you convert it into radians, it is going to be what? 2 pi. And this one is the total distance that an object which is oscillating can reach or can acquire. So meaning to say that what we are going to have here on part of theta is going to be what? 2 pi. So we are going to have 2 pi here, then divided by 10. You know where this 2 pi is coming from? This 2 pi is coming from when you convert this 360 into radians. So you know how to convert this one. You say 360 multiplied by pi divided by 180. 180 into 360, that is 2. And then you divide, you multiply by pi. So this is where it is coming from. Now let's do this. These formulas are very, very important, and you need to know how to find them. Since this angle here is in radians, isn't it? This angle is in radians, and this is the period which is measured in seconds. And this one here is in radians, and it is measured in lads. So therefore, this angular velocity, which is written like this, is going to be measured in lads per second or rad per second. Where is this one coming from? Distance measured in lads or radians, which is this one. Then per is more like division. Then we want to say that period is measured in seconds. So therefore, angular velocity is going to be measured in rad per second. So that is very, very important to know. Alright. Let me also include the same formula. So the first one, it was angular velocity, which is equal to theta divided by t. And we know to say that this theta here should be radians, and the total distance that an object can acquire in a complete circle, it is 2 pi, which is also 360. But in this case here, we focus on 2 pi, then divided by 10. Now what I'm going to do here, I'm going to do the assumption. Let me take this one here. We have frequency equal to 1 divided by 10. So let me just make t the subject to the formula. So t is going to be equal to 1 divided by what? By f, which is the frequency. And here we know to say that angular velocity is equal to 2 pi divided by 10. So I can just say, I take this one here and put it here. What am I going to have? I'm going to have 2 pi divided by 1 divided by frequency. And we know to say that here there will be a reciprocation. Frequency divided by 1. Then here what are we going to get? We are going to get 2 pi f, which is the frequency. So therefore, angular velocity is going to be equal to 2 pi f. So in most of the textbook, you're going to find this one here as angular velocity being equal to 2 pi f. This one here is not the only formula. As we have investigated here, there is also this formula here where you can say angular velocity is equal to 2 pi divided by t. Now what is important is now you knowing how to use these formulas. Here I'm just showing you where these formulas are coming from and how you can come up with them. Right, so with that, let's also talk about this one. The next formula is how to find the period. This one is also the next formula. You and I, we know that the period can also be found by 2 pi then root of L divided by G. But in this case here, we're not dealing with length and gravity. So rather, what we are going to have, 2 pi, then open bracket, K divided by M. Spin constant divided by the mass of an object. So let me just erase this part here on top. So these formulas are very, very important. So let me write the formula for frequency, which is this one here, and also the formula for angular velocity, which is this one here, or we can say angular velocity is equal to 2 pi f. Then apart from that one, we have also this one here, which is period, which is equal to 2 pi root of K, which is the spin constant, divided by the mass, which is M. So from these, let's also come up with other formulas that you need to know, and these are very, very important. Then from there now, you need to know now how to use these formulas. But remember, this one is measured in rad per second, even this one same as this one. Then frequency is measured in hertz, period is measured in seconds. What I'm going to do here, we have this period here, which is equal to 2 pi, then root of K divided by M. Just write like this, divided by M. So what I'm going to do here, I'm going to do this. Have you seen this one? Let me make T the subject to the formula here. Then T is going to be equal to 2 divided by W. Have you seen here? So meaning to say that I can get this one here and put it here and see what I'm going to have. So if I say 2 pi divided by the angular velocity, this one is going to be equal to 2 pi, then root of K divided by M. Have you seen this one? So from here, if I want to make angular velocity the subject to the formula, you and I we know that these two, they can cancel each other. How? Let me do this. Let me multiply throughout by 1 over 2 pi. Here when I multiply 1 over 2 pi, these, they are going to cancel each other. Then what am I going to remain with? I'm going to remain with 1 divided by angular velocity, and this one is going to be equal to root of K divided by M. Now this is the inverse. 1 over W, which is the angular velocity, is same as W to the power negative 1, which is the inverse. Now inverse, the meaning of inverse is like this. If you have A divided by B and you want to find W to the power negative 1, which is the inverse, and you want to find W, meaning W, which is the angular velocity, is going to be equal to these, they are going to interchange the position. So we are going to have B divided by A. So we are looking for angular velocity. So angular velocity is going to be equal to root of, the denominator is going to become the numerator and the numerator is going to become the denominator. So therefore we are going to have M divided by K, mass divided by the spin constant. So if you have the mass, you also have the spin constant, you can easily find the angular velocity. This one is very, very important. Then from here, that's a good thing about physics. You need to know how to derive formulas, and then you're going to enjoy physics, I can tell you. Know how to derive formulas, then from there you're going to enjoy physics. So we have angular velocity, which is equal to root of mass divided by K. But we also know that angular velocity is equal to 2 pi divided by T, which is the period. It is also equal to 2 pi multiplied by F, which is the frequency. So for physics, that's the reason why I was saying that these three things that you need to know. The first one is you need to know the formulas. Apart from that one, you need to know how to collect data. The data is going to help you to know which formula you're going to use. Let's say, for example, you have the mass. Let's say you have the mass 250 kgs. You also have the spin constant, which is 1.3 multiplied by 10 to the power 3 Newton per meter, and you're being taught to calculate what? The angular velocity. But you just know this formula. I mean, this one doesn't make sense because you don't have time, isn't it? Or you don't have the period. Even this one here doesn't make sense because you don't have the frequency, so you can't find. So that's the reason why I was saying you need to know how to collect data. You need also to know situations in which they ask questions. So we have started with the formula. The next thing I'm going to show you how to collect data. Then the last part, you need to know how to answer questions in different situations. So this one is very, very important. Let's say, for example, if we try to square both sides, what are we going to have? We're going to have angular velocity squared, which is going to be equal to m divided by k. So from here you can find the spin constant. You can find the spin constant, or you can find the mass. Right? So if you want to find the spin constant, what are you supposed to do? Let's say we multiply 1 over m throughout. What are we going to have? We're going to have 1 divided by the spin constant, which is going to be equal to angular velocity squared divided by m. So this one is the inverse, isn't it? So we're finding k. So this one is going to be equal to m divided by angular velocity squared. So this one, very, very important. Now, let's try also to look at other formulas that you need to know. Of course, some of the formulas I'm just going to introduce them as well, be answering questions in the next videos. But as for this one here, let me show you this one. We know to say that period is equal to 2 pi root of k divided by m. What about frequency? So frequency is going to be equal to 1 divided by, we have 2 pi the root of k divided by m. So how can we go about this one here? Alright, so for this one, it can be written as frequency, which is going to be equal to, we know to say that this is 1, isn't it? And this one is period. So I can say we have 1 over 2 pi. Okay. We also have 1 over root of k divided by m. So these, they are multiplying each other. Alright. So what we are going to do here, for us to find the frequency, so you and I, we know that to eliminate this one here, it's more like we need to introduce the inverse here, isn't it? It's more like we introduce the what? The inverse for us to eliminate this negative, because if we cross multiply here, you're going to find that what we are going to have here, we are going to have 2 pi then root of k divided by m multiplied by frequency, which is going to be equal to 1. And here definitely we are going to multiply by, we are going to divide by f, even here by f. Here we are going to remain with 2 pi root of k divided by m, which is equal to 1 over f. And this one is the inverse. Okay, this one is the inverse. So what are we going to do? These, they are going to interchange. So frequency is going to